Okay, so I wrote some really, really simple and probably even too simple Mathematica code to look at the Pulitz conjecture for music. So clear A, just make sure that if our variable A has anything assigned to it at the beginning, we just get rid of it all. So we're going to start out at 5, and we're going to go out through 100 rounds of the. So I'm not actually stopping when we get to 1. I'm just going 100 times and seeing what happens.
All right.
And it says if mod A2, that says if A mod 2, what does mod 2 mean?
It's either
The
0
remainder
or
when
1.
it's divided by 2.
Okay, so right, so when I look mod 2, if that is 0,
So if it's even,
I divide by 2. So that for the next one in the sequence, AI plus 1 equals AI divided by 2. And if it's not even, I multiply by 3 and add 1.
all right.
Okay, and I do that 100 times. Then I make a little table of sounds using the A's. But now I make the sounds mod 24 just so I don't have sounds going up and down all over the place.
Okay.
Okay, but I could pick any number there. In fact, let's do that. What number would you like to restrict the highest to the lowest sound?
50.
50? Okay. We can play with that later. And then I just take a random integer for the notes, either 1 or 2, and that just, you'll hear the notes vary a little bit. That just kind of makes it fun.
Yeah.
And these are going to be short notes, so this will play quickly. And so here's what it looks like for 5. And you're going to see so why do I get that repeating pattern?
Because you
It's
hit 1.
in the loop now.
It's in the loop. Okay. So 5 goes to 1 very quickly. In fact, as we saw in our last video, we actually had a 5 in there.
Yeah, it goes
Yeah.
to 16,
16.
and then
Yeah.
Then 8, 4, 2, 1.
Okay. So let's pick another starting point. So give me a different starting point.
Let's see what about 7 maybe.
All right. So 7 lasted a little longer. So here's what 7's going to sound like.
back again.
All right.
Loop.
So we got to that loop
What
pretty
about
You do big numbers with this.
quick. Okay. Give me another one. Give me a slightly bigger one.
maybe 113?
113. Okay.
13.
Sorry. 113. Let's see what that sounds like.
Oh, it looks like it goes pretty quickly again.
Turned out that one was quick. So big numbers sometimes
Go
don't
quick.
last as long. But let's see, let's listen.
Back down.
Back down to that loop. I'm going to lengthen out the notes a little bit. I'm going to go from 2 to 3 just so we can hear the notes a little more. Okay. So 113 didn't work. Well, it worked, but it wasn't long. So let's try another number.
Let's try 172.
172.
1172.
Is that what you wanted, or did I
No,
mistype it?
that's what you mistyped.
Okay. 1172.
One.
Ooh.
This one goes
Longer.
longer.
All right. And now I'll make one that probably lasts longer than 100 by starting it at just some randomly huge number.
Okay.
It doesn't even get there.
Maybe we should.
It doesn't get to the repeating part.
Yeah.
Yeah. Did it almost? It got to that part. It was like beeping.
Oh, yeah? But
Yeah.
not, but it must not have been the same part because it didn't get stuck there.
Oh, it's mod 24, so it must have gone a really high note.
Yeah. Well, it's mod 50. We changed it to mod 50.
Mod 50, so it must have gone high.
So that's kind of fun to hear what it sounds like. But what I want you to do now is change the procedure somehow to make a different Collatz conjecture.
Okay.
So what could you do? Actually, let's make this a new movie.